So as with all different types of compounds, we have to review nomenclature. So alkenes are no different. We already know how to name alkanes, which are all single-bonded hydrocarbons, but an alkene we know has at least one carbon-carbon double bond. So that's the only difference between what we've looked at before, and we have to assign a locant to that carbon-carbon double bond. So as we've done in the past with alkanes, we first identify the parent chain, right? So that would include the carbon-carbon double bond. Not only is it the longest carbon chain, but it has to include this double bond. We will identify and name any substituents such as, halogens, chloro, bromo, or other carbons such as ethyl or methyl groups. We'll also assign a locant as far as where the carbon-carbon double bond is with the lowest numbering possible. So not only do substituents have a locant, now also the the carbon-carbon double bond does as well. And the alphabetizing, right, the alphabetical order, that doesn't change. We always ignore prefixes like di, tri, etc. Iso is an exception. And we'll place these substituents in alphabetical order, and we'll make sure that a locant is given just before the parent name. Or we could also put it just before the "-ine" suffix, like we could have something like hept 2-ine, for example, or we could also call it a 2-heptene. So in these examples here, we see a 5-carbon chain, right? So this is my alkane. And then as soon as we install that double bond here, we have an alkene. So same parent in this particular example up top here. But when we look at the 2 chains down here, we can see that if the double bond is here, right, in this location here, our longest chain with the double bond would only be 7 carbons, right? 1, 2, 3, 4, 5, 6, 7. Whereas in this example here, we have almost the same molecule, but the longest chain, the parent chain, does not need to include the double bond, so we actually have an octane here. So again, make sure when you're choosing your parent that you choose the longest chain that has the carbon-carbon double bond. Let's see here. So in this case here, we want to make sure that our lowest number is given to the double bond location. So in this case, we have a 7-carbon chain, longest chain, either way that we look, from left to right or right to left. But we want to give the lowest locant, so we want to call this 2, right? So we would call this a 2-heptene as the parent, not a 6 or a 5-heptene. So the rest of this compound, right, now that we have the numbering down in the right direction from left to right, let's look at our substituents. So would we call this a 5-5-6, right? So we have our substituents on the 5. We have another substituent here on the carbon 6. So we have a trimethyl, right? For our 3 methyl group substituents, they are on the 5-5 and the 6 carbon. And as I noted before, we could call this either a 2-heptene or a hept2-ene. Last but not least, right, we always have to give whether it's E or Z configuration. So we'll again draw kind of like a dividing line here in our double bond, and we see that our 2 highest priority substituents on either side of the double bond are on opposite sides because we have, right, hydrogens here. So our opposite side would be the E designation. So overall, this molecule will be named as E556 trimethyl hept2-ene or E556 trimethyl 2-heptene.